Shall we start, or we should wait for a couple of minutes for others to join? In the meantime, if you have any doubt, any question, you can let me know. You can ask, no problem. Okay, so in the last classes we have started discussing about those gears and gear trains. So there we have seen what is gear, why it is used, there are different application, different possibilities that we can get. So later on we have discussed about friction wheel from there that to any discuss about our gears only, to analyze gears only. In the simplified version we have discussed about the friction wheel. There we have seen how the pitch line velocity for both the mating gears, which in terms of our friction wheel only we have drawn. So how the pitch line velocity is same for both the mating gears. So those things we have seen. Then considering the no slip condition, we have checked. We have seen how basically the velocity ratio, or the velocity ratio of the two mating gears, and the size of the gears, how they are linked. So there we have seen that basically if omega 1 by omega 2, that we are considering suppose driver and driven, that particular suffix. Okay, so there we have seen that it is inversely proportional to the radius of the square wheels. Okay, so ultimately if it is inversely proportional to the radius, so it is similar to inversely proportional, being inversely proportional to the diameter also, and ultimately the radius or the diameter of this particular gear blank or the gear wheel actually gives you the indication about the size. So there we have seen that means the whether from there we can very easily obtain whether the bigger size gear or the smaller one which is going to rotate faster and all. And from there, from that indication, we can take the knowledge of whether we have to select, if we are talking of suppose increasing the velocity ratio or the increase of speed from the driver to the driven. Suppose 500 rpm is available in the driver, if you want suppose 1000 rpm in the driven. So if we're talking only in terms of like the size, okay, so whether we have to go for a another wheel, another gear which should be in mass, whether it should be bigger or smaller than that, how many teeth etc it should have, that kind of indication, somewhat indication we can get. So in general, the size of the gears and the number of teeth which are generally there in the gears, they are also sometimes it is proportional. In general, the bigger size gears, they generally have more number of teeth, okay, compared to the smaller size gears, okay, but it is not always like only like that has to happen. It is not like that, okay. But in general practice, we are talking that if nothing is being mentioned and only suppose the size of the gears that you know, and if nothing is mentioned, you can, it is safe to assume that as if the bigger size gear will have more number of teeth and all, okay. So it's if nothing is mentioned, that can be considered. And similarly, like in general, we have discussed that the while we are talking of two gears which are in mass, then if nothing is being mentioned, then generally the bigger wheel is considered as a gear, okay. Wheel, by the word wheel we are mentioning about gear only, okay. So sometimes we use the word gear blank to indicate the gear, okay. So basically gear blank is the piece from which from where we from on which basically we cut the gear teeth, so that is known as the gear blank. That means from the gear blank we manufacture the gears. So this friction wheel or the circular diagram that we are drawing to indicate gears without showing the teeth of the gears, okay, those can be considered as a gear blank. Okay, now already we have discussed how why we draw it like circle. We sometimes we even don't show the teeth and all to while analyzing the, you can say, these gears and all, okay. So that thing already we have discussed, and today towards the end, like we have talked about the different materials and the properties of the gears which are being manufactured by different materials, where we can use, or if we have to go for a particular application, depending on what are the factors which depends or which dictates the selection of the gear material. Those things also we have discussed. And today initially we are going to discuss about the classification of gears, and previous one type of classification already done in the last class, that is based on the velocity of the drive. And today we are going to discuss about the classification of gears based on the relative position of the gear shaft axis. So the shaft axis, how axis dictates and all those things already have discussed. So initially, divisions already we have discussed, like parallel sub for using parallel sub, we can have spar gear, like can pinion helical gears, etc. And these things already we have discussed. So now today we'll be going initially for the spar gear. So what is the spar gear, or what is the, like you can say, the main, you can say the what is the spar gear and when it can be used, etc. Those things we are going to discuss today. Okay, so now spar gear, we are saying that already it's a kind of gear, okay, one of the very simplest type of gear, okay, which is generally used to transmit torque between two parallel shafts. Okay, so now in this particular both the figures, we are showing two different views of the gears which are in mass. Now in this particular figure, from this particular upper figure, if you look on, okay, so then this particular portion, it shows the shaft position or the axis about which this particular gear is rotating. So we are saying two gears are in mass. So this is a smaller gear, this is the bigger one. Okay, they are in mass. We are talking of the spar gear. So now in that particular case, this is one view of it, and this is another view. Okay, the pink one. Okay, and now here this is the shaft. Okay, we are talking of this particular shaft, and another shaft is here, this one. So as you can see, this shaft axis and this shaft axis, they are basically parallel. So that's why we this is the condition of this parallel shaft. So now to transmit torque or motion from this shaft to this shaft, okay, through the help of this particular gear, we can use spar gear. Now in the spar gear, how we can know whether it's a spar gear or not, or what kind of teeth we have in the spar gear. So basically, the spar gears, they have got straight teeth which are parallel to the axis. Okay, and that kind of teeth they have. So that means in this particular view, if you look at, so here if we project this particular point, actually this particular gear and this bigger gear, they are in mesh. That means, okay, we are showing with the help of to ease our task. Okay, we are showing with the help of two circles. Okay, so now these two asparagus we are talking about this particular axis or this particular sub-axis, it is having the rotational motion, and as it is being matched with this particular gear, whose axis of rotation is here or the shaft position is here. So basically, with the help, whenever this particular gear, bigger gear, is getting the motion, the with the help of the motion will be transferred to this particular shaft also. That means ultimately the shaft also will rotate. Okay, so now in that particular case, this particular location where the two gears are in contact, and basically we already know that if you look at from this particular figure, below figure, so basically the teeth of the gears are in contact only, and at a particular time not all of the teeth are in contact. Okay, but a particular contact ratio will have, okay, a particular pair of it, or maybe 1.6 or whatever. Those things we'll be discussing later on, but we understand by contact ratio and all. But we from normal knowledge, layman's knowledge, we know that at a particular location only we are having this particular contact, and generally the teeth are in contact from both the meshing gears or the mating gears. And as we have already discussed in one of the classes, if you look at this particular point position where actually the teeth are in contact, and if you draw a circle for this bigger and for the smaller one, then they will look somewhat like this. That's why we also represent gears like this while analyzing purpose, to use or to ease our task. Now if this particular position if you project, then basically you'll see here we are making it like darker. Okay, and this look will be like from it is kind of top view. Okay, so here this is the gear portion, these are the shaft position. So for this particular case, this is the gear portion, and this much is the shaft portion. Okay, so now in that particular case, so what basically is happening, so here this they are missing. Okay, if you look at properly, so here basically we are drawing with a you can say darker, we are making it darker. Okay, so as to represent this particular position, that means they are from here, actually they're in contact here, they are in mesh here. And now the teeth of the spar gears, they are always parallel, straight, and they are parallel. That means they are cut like this way, this way, this way, this way, and like that. And the teeth are parallel to the suffixes. That means they are not inclined like this, but they will be cut like this. So if you look at that, means if you consider as if this is the 3D, the thickness if you consider, then they are cut. Okay, so they are having straight teeth parallel to the axis, and because of this they are not subjected to axial thrust due to tooth load, because they are having straight teeth. Now how this particular spar gear they engage. So now, if you look at this particular animation, okay, so what basically happens, we know that this is one particular view only, and actually they are 3D element. Okay, so the thickness they along the plane, they actually towards you can consider as if the thickness is insiding, like it is there, thickness of the teeth is there, okay, as if it is extending into your that particular plane that you are seeing. Okay, the screen that you see, you can consider that as your plane, and you can consider as if the depth is there. Okay, that is the thickness that you are getting. Now, in that particular case, so what basically happens, we know that we are talking about like the contact is there with the in the teeth only, teeth from both the mating gears. That means gear A and gear B, the contact is with respect to the teeth. Okay, they should be masked. Okay, and now at the time of engagement, okay, so what basically happens, the contact. So suppose if we are talking of this particular gear and this particular gear which are in contact, now if you consider as if they start rotating, okay, so gradually, as we already know, the gradually only the contact happens between the teeth. Okay, not all the teeth are there in contact at the same time. But if we think of this particular two gears with their thickness, okay, that is the thickness is there, so now, or the width of the gear is there, now during the time of engagement of the two gears, that means two gear teeth we are talking about, the contact, it extends across the entire width, okay, which is on a line parallel to the axis of rotation. Now, because of that, what will happen? So there will be, as suppose initially this particular pair of teeth is in contact, next suppose the next pair of teeth will contact, will be in contact, next suppose the next, and gradually like that it will come in contact. But during the time of engagement, the contact extends across the entire width. Okay, so throughout the width of this particular tooth of suppose gear A, and throughout the width of this particular teeth, suppose from gear B, the whole width is in contact. Okay, and basically as it actually it extends like a line which is parallel to the axis of rotation, because the teeth are parallel to the axis of rotation. Now, because of that, what will happen, all of a sudden there will be sudden load application, and because of that, high impact stresses and some excessive noise is there at high speed if you use spark gears. So sometimes you can have a cut that kind of sound, like at the high speed. Okay, that kind of noise you can have at the noise speed, which actually indicates sudden contact, sudden engagement of the two gear teeth from the two machine gears, and because of that, actually this kind of sudden load application will be there, and high impact stresses as well as excessive noise will be there at the high speed. So from that point of view, sudden load application point of view, that means it is limited to some limited by the application of load. Okay, so that is the thing. Understood how basically it is happening, how the engagement is there, or why the sudden load application is there when the teeth are coming in contact. Let me know. Okay, I hope you have understood. Now, this engagement, as we are talking, that would the gears should be meshed properly. So now this meshing or this particular engagement, it can be external or it can be internal. So in this particular figure, whatever you see, basically it's a external arrangement or internal arrangement that you think. So it's a external arrangement of or external meshing. So in case of internal arrangement, that I will show in the subsequent slide. So you will have the once again two gears, and if you are talking of the internal, okay, and there is some word we use, that is the bigger wheel. Okay, we consider the larger wheel as the annular wheel and the smaller one as the internal pinion. Okay, and once again, just like in the previous classes we have discussed, so now if we're talking of a two properly meshed external spur gears, so they rotate always in the opposite direction. Suppose that means if the driver is rotating in the clockwise direction, if you consider suppose B as the driver, suppose it is driving suppose A, then if B is rotating in clockwise direction in that particular time, okay, so during this engagement and all those force transmission, torque transmission will happen, and A will rotate in the anti-clockwise direction. So that means externally meshed spur gear, they rotate in opposite direction. But if we talk about this, suppose this particular figure, if you look at, they are internally meshed. So this is the suppose bigger wheel and as the annular wheel sometimes, and this is suppose is the uh, pinion, okay, the smaller gear. So now from this figure also you can see the below uh, extreme left only. Okay, so this is the bigger wheel is not where the internal teeth are being cut. So and ultimately with this we have this particular smaller gear. So this kind of arrangement is known as the internal meshing. So we have internal teeth here, okay, on this particular bigger gear, and it meshes with the external teeth which are cut on the periphery of the smaller gear. So this arrangement is internal meshing, and this arrangement, if you look at this particular figure, okay, so here this one is, this is the external meshing, okay. And if you look at, so throughout the length, actually if this is the axis, this way we'll have the axis, okay. And in that case this tooth are parallel, okay, tooth are straight and they are parallel to this particular axis. So this is how you can, by looking at the gear, you can indicate whether it's a spar gear or not. Similarly, we can have rack and pinion, that also we are going to discuss. So we can have spar, rack and pinion, where the teeth profile is kind of the teeth is kind of spar gear. Okay. So up to this much, I believe all of you have understood. Let me know about spar gear, whether you have understood or not. Similarly, external meshing, internal meshing. So in the internal meshing, what will happen if it is rotating in the anti-clockwise direction? The bigger wheel also will rotate in the anti-clockwise direction only because of the internal meshing. But in case of external meshing, it is just the reverse. Both the wheels will rotate in the opposite direction. Okay. Next, we'll be talking about rack and pinion. So this rack and pinion, basically you can consider rack and pinion as a special case of spar gear. So how it is kind of, how we can consider like a special case, that we'll see later on. So now what happens in the case here, what basically happens, the spar gear, the gear, this is the gear we'll consider, it meshes with a gear, another gear which is a kind of in a straight line fashion. So on this particular this is a kind of straight line, okay, straight line kind of thing. Okay, here we have cut the gear teeth and it meshes with this particular circular gear. Okay, so this particular arrangement is known as the rack and pinion arrangement. So here is the rack, okay, the straight line portion, straight gear, it's known as the rack, and the gear circular one, the gear like profile, it's known as the pinion. And now what we can, by the look you can very easily say, or maybe from this figure, so when the pinion will rotate, what will happen to the rack? So rack will translate, okay, that will move like this, translation motion, and pinion will rotate, right? So this is what we can do by the application of this kind of gear pins, rack and pinion arrangement. We can convert rotary motion into translation motion. That means if we move this, if we're supposed to, we have this particular setup of rack and pinion which are properly in mesh, then in that particular case, what will happen? So if suppose this is the rack portion that we have, okay, don't mind the drawing, and suppose this is the, this is the pinion, suppose, okay. Okay, don't mind the quality of drawing, it's very bad now. Okay, so in that particular case, when it is moving like rotating like this, okay, the pinion, okay, so what we can expect actually due to this engagement, okay, so this way your translation motion will be there, or vice versa is also possible. That means if you can give motion to this rack, okay, this is the straight line portion is the rack, I'm simply writing like that, okay. And this is the pinion. Okay, so in that particular case, rotational motion is being converted to the translation motion of this particular rack, or vice versa also is possible. Translation motion, if you can give to the rack and pinion which are in properly meshed, then rotational motion you can expect in the pinion. Okay, so this is how you can even use gears to get this kind of motion. Okay, so now why you are saying that this rack is a special case of, is the rack and pinion is a special case of spar gear? Because this rack, which is a straight line portion, we can consider as if it has got its diameter or the size is it's a infinite diameter. Why? Because see, any if you look at this, so the straight line actually, the rack we are saying that it's a straight line portion. Now, if you suppose have this particular circle, suppose this circle smaller, okay, then if you only consider suppose this particular portion from it, suppose this the upper portion, okay, if you look at the uh, okay, so now if you look here in this particular portion only, okay, this particular portion only if you consider, okay, you can very easily obtain suppose it's a kind of like arc we have, okay, but if you keep on extending the diameter of this particular circle, okay, suppose this is a circle, okay, then you can see how it is changing, or maybe another circle you can consider, keep on making it big, okay, maybe another circle if you consider suppose maybe another circle and all, okay, then actually if you keep on increasing the diameter of it, what you'll see if you look at a particular portion from it, okay, like this suppose this mass, and here suppose only this one, if you keep on increasing the suppose size of it, then this portion if you look at, okay, so it this portion from here to here, it tends to be a straight line. Yes or no? This person keeps becoming like it looks like a straight line. Suppose if we have another bigger, you can say circle, then suppose this is it's a very big circle. Okay, consider as if the art. Okay, so we say now there is. I believe all of you all now I know nowadays already know there is even a society, the mad society known as the flat earth society. They tend to believe that art is flat because the size of the art compared to us is so huge that for us it looks like a flat thing, but actually it's a circular only. Okay, so somewhat spherical. Okay, so in that particular case, so rack also, even though you look at this particular rack as a kind of straight gear, okay, but it can be considered as a part of a circle having infinite diameter. Okay, so, as if suppose from this particular whole circle we are only considering this, so it tends to be, it looks like a straight line, right? So this is the case with rack and pinion. That's why we consider rack and pinion can be considered as a special case of spar gear. Okay, understood? Let me know whether you have understood or not up to this much.
Understood,
Someone?
sir.
Yeah, okay, thank you. So next we'll be discussing about helical gears. So in the spar gear, what we have seen, the teeth are straight and parallel to the shaft axis. Now in case of helical gears, basically the teeth are curved, okay, and they are helical in shape. So if you look at this particular figure, you can see that along the axis, if you see, if suppose this is the axis, okay, or maybe from this figure it will be more evident. So if this is the axis, then they are like not straight, okay, they are curved, okay, and generally helical in shape, and this particular, they are making a particular angle, that means if they are curved and making they are helical in shape, and if you with respect to the shaft axis they are making an angle, okay, and the angle between the teeth and the axis of the wheel is known as the helix angle. So you'll see this helix angle here in this particular figure, and in that particular case, if we're talking of this particular helical gear, so they can be in the oriented suppose in the right hand direction or left hand direction and all, okay. So now if we are talking of this helical gear, and if we want that two helical gear, okay, they should be in properly meshed. So in that particular case, the one of the condition they has to fulfill, and it is both the meshing gears, both the meshing helical gears, they must have the same helix angle. That is the orientation of the teeth with respect to shaft axis. That angle must be same for both the helical gears. But the teeth should be of opposite end. That means if suppose this gear, if you look at this gear and this gear, and we have shown another view of this. So for they are meshing gears, helical gears. Okay, so if the teeth for this particular helical gear is oriented like this, okay, this way, Then for this gear, which should be in contact, it should be oriented in this direction. Okay, that means both the teeth from the both the meshing gears, the helix angle should be same, but they should be of opposite hand. And now, in the case of helical gear, what is our advantage? So there is the advantage of gradual engagement of the teeth, which makes the helical gears operation comparatively very smooth and quiet compared to the spur gear. In case of spur gear, what we have seen, the angle, the teeth were straight, and all of a sudden, at the same time, from both the meshing gears, the line contact is there throughout the teeth, throughout the width of the teeth. Both the gears they just meet suddenly, okay, and extra loading also is there, sudden loading also is there, and that sound etc. also is there. And now, as in this particular case of helical gears, they are curved and gradually they come in contact. So in that particular case, so the gradual engagement of teeth happens, okay, not the whole teeth with it comes in contact at the same time, but as both of them are helical, okay, they are oriented there. So in that particular case, gradual engagement of the teeth make happens, and because of that, the operation is comparatively smoother and quieter, okay. And in that particular case, as there is no sudden load application and all, okay, so here this helical gears we can go for higher velocity application as well as greater load carrying capacity it has got compared to your spur gear, okay. So in that particular case, this helical gear, it may be single helical gear or it may be double helical gear also. That means two helical gears it can be engaged to just like in this particular figure, or like this, okay. So in that particular case, you can see it's a two double helical gears, okay, or in this particular case this is a single helical gear. So in the double helical gears, actually, like, it has got certain advantage over a single helical gear also, that we will also see. But one of the thing, as the angles, that's the teeth, not the angle, okay, as the teeth are making their curve and making an angle in case of helical gears, so there is an axial thrust, okay, as there is a force component along the gear axis, okay. So in case of single helical gears, there is a problem of having an axial thrust, okay. But later on we'll see how it can be avoided and all. But once again, thus apart from single helical gear, we can also have double helical gear like this, okay. So these are some of the other figures. So helical gears, okay. So you can see how the teeth are curved and making an angle, and there, if you can visualize if as if they are being rotated, okay. So in that particular case, you can see that the teeth will come in gradual contact. Not all of a sudden the whole teeth thickness will not come in contact. So it becomes quieter, and proper engagement also will be there, and so load carrying capacity is more also. So similarly here you can see, okay, it's kind of a wormhole structure, but the teeth are helix. That's why we are talking it as, considering it as an helical gear. Next, there is another type of gear known as the herringbone gear, which is somewhat similar to your double helical gear, but there is some a very minor difference. Sometimes they we even use the words interchangeably, but there is a very small difference between double helical and herringbone gear, and I want you to find out that difference. Okay, when we'll be calling it as double helical and when it is herringbone, because in both the cases you have seen as if two gears, okay, two helical gears as if they are connected together, okay. So it forms a kind of herringbone gear. Now in the case of single helical gear, what we have seen that there is a thrust, axial thrust component that is there, which is unbalanced, okay. And because of that, definitely we don't want any thrust force and all, okay. So unbalanced force we generally don't want in a system. So in the, to avoid this axial thrust, so what we can do, we can two helical gears of opposite head. So this helical gear, suppose this way it is oriented, the teeth are mounted oriented, and for the other one there is another wheel, okay, it is oriented like this. So it can be mounted side by side, okay, as if they are connected, okay. But one is having this hand, another is having the teeth of opposite hand, okay. So in that particular case, what will happen, this particular portion also will have a side thrust, suppose in this particular direction, and the other portion which is in opposite hand also will have a side thrust, but in the opposite direction. And now these two side thrust component will get cancelled out. So there is now quite a operation is already the advantages of single helical gear already we have, along with we have now a balance, there is no axial thrust component. Okay, so because of that, this herringbone gears, it can be easily used for heavy machineries. Okay, so and now with respect to what is double helical and herringbone gear, you will find out the difference. Understood?
Yes, sir.
Okay, thank you. Next, we'll be talking about these different discussion we have done with respect to this parallel stuff. Okay, now we'll be talking about how motion transfer you can have in between the intersecting stuff. So for that, we have one of the very good arrangement known as the bevel gears. So now, what is bevel gear? So or why it is used? So these bevel gears, they are used to transmit the rotary motion between intersecting stuff. So now if you look at this particular figure, suppose this is the axis of the this is the sub axis, this is another sub axis, so you can say they are meeting or they are intersecting here, so they are intersecting stuff. So now our intention maybe sometimes if we I want to have rotational motion from this direction to this sub, okay, which is in this particular direction. So in those cases we can use a gear arrangement known as the bevel gear. So what is the possibility with respect to bevel? So the sub axis, okay, it may be inclined at any angle from 0 to 180 degree, which is theoretical angle only, 0 degree to 180 degree. That means the orientation is possible. Okay, it's not only that only this way only they has to be oriented, but other orientation also is possible. Okay, suppose one axis is this, another axis is like this. So in that case also we can go for specially cut bevel gear. Okay, so that's possible. But these are the theoretical values only, 0 to 180 degree, but we don't go for that kind of extreme ranges, but theoretically it's possible. Okay, so next, if you look at this particular figure, what will happen, what you'll see, actually the teeth, if you look at this particular figure as well as the below figure, if you look at, okay, so actually what happens, the teeth of this bevel gears, they are formed on conical surfaces. Okay, and the straight tooth can be straight tooth also, it can be spiral also, but actually the tooth are actually cut on spheric you can say, okay, the teeth are formed on conical surfaces, so it is something like this. So suppose I believe all of you already know about cone. Okay, so it's a cone, all of you already know. Okay, so now this actually this bevel gear, okay, here the teeth are cut on this particular, on the surface of this particular cone. Okay, and depending on where you're cutting it, okay, actually you can have bevel gear of different sizes. Okay, but actually they are cut on this particular cone. Okay, so the teeth may be parallel also, can be this. So you can consider these bevel gears. Okay, these gears, sorry, so these gears, okay, this portion, these tooth are cut on a conical surface. Okay, so if you consider suppose as if this particular location, so you will consider this portion is as if cut on the conical surface. Okay, so sometimes this question is being asked. Okay, so bevel gears, what is on which surface basically it is cut, so it's a on a cone or conical surface it is being cut, that's why you'll see this edges, they are like this only. Okay, and the engagement is like this. Okay, so now what we can do, that means from this particular axis through this arrangement, we will get arrangement which are connecting like this. So what will happen if this rotates, then ultimately through this engagement of this gears, okay, bevel gears, so this particular shaft will get this particular rotational motion. Okay, so here you can see this one axis is like this, one axis is like this. Similarly we can have arrangement like the other view we can have like this also. Okay, So one of the very good use, or one of the very versatile use of this reveal gear is in this particular location, the 90-degree conversion. Okay, so sometimes there is another word. Okay, miter gear. So what is this miter gear? So gears of same size which connects subs, two subs which are at right angles, they are known as the miter gear. So you may sometimes come across the words miter gear. So in that particular case, you must automatically understand that this miter gear arrangement means both the gears, this one and this one, they are of same size, and this axis, okay, angle between these two sub, it is 90-degree. We have discussed that in case of bevel gear, it may range from these two extremities, okay, 0 to 180-degree possibilities is there. But miter gear, it is a specific case when both the meeting gears, they are of same size and angle is 90-degree. And this bevel gear arrangement or the miter gear also, okay, they are commonly used. You'll see this used in the differential of automobile. Maybe you might have seen the like in the case of different vehicles, maybe truck, buses, etc. Like towards the rear wheel, okay, you might have seen in the axle which is connecting the rear wheel, okay, both the rear wheels, in between you have a another globe kind of structure. So basically within that housing we generally have the differential. Okay, so what is the use of this differential? So this differential basically, what happens here, we already know that actually from the engine side we have got the power transmission, okay, and so from engine to the propeller sub, actually the shaft is rotating, okay, which is coming from suppose this side, okay, from engine side. This is suppose is the engine, sorry, this suppose is the engine side, and through the propeller shaft, suppose it is coming towards the rear wheel, and we have got the rear wheel like this. This is the rear wheel axis on which both the rear wheels are being, this rear wheel and sorry, this rear wheel and this rear wheel, suppose they are being mounted. Okay, this is the engine side. It's the engine. Okay, so this propeller shaft, it is we are getting the rotational motion. Okay, propeller shaft is rotating, and now our intention is we should be able to give motion to these wheels, right, in this particular direction. That means this side and that side. Okay, so in that particular case, the arrangement that will, which is generally housed here, okay, we have the differential here. And what basically does the differential have? It has got this particular bevel gear arrangement there, okay, which is spider gear and all. So in that particular case, what happens, we are able to get the rotational motion from the propeller shaft to the this rear wheel axis. Okay, this is one thing. And why the name is differential? It is coming from difference. Okay, difference means different for the thing. So now we already know, if we from our steering wheel mechanism, we know that if we are talking of taking a turn, okay, suppose this is a turn, okay, about this is suppose is the center. Okay, so all the turns, they have got a radius of curvature. Okay, suppose this is the radius of curvature, this is the radius of curvature for the inner side and for the outer side of this particular. Suppose this is r, this is the smaller. Okay, so we know if whenever we are talking of a vehicle and it has to take the turn, so in that case both these wheels, okay, the rear wheels, both of them has to traverse different length, right, the same distance. Okay, this has to, as you can very easily say, this has to, the outer wheel has to traverse a more length. Okay, so in the same time, that means we should be able to differentiate the this motion that is being given here, suppose omega 1 and omega 2, so it has to be differentiated. Okay, and this is what this differential does. One thing is, from this side, okay, propeller shaft is having the rotation, okay, was omega, this angular velocity. Okay, so from here we can give the motion to this side and that side, and we use this differential, and which is having the all those bevel gear arrangement. And next thing is, we can differentiate the this velocity of the two wheels also, which is very, we can very easily see it's required, because whenever we are saying of taking a turn, so both the wheels, as we have this a finite width we have, okay, so finite distance is there, finite width is there. So in that particular case, while taking the turn, you can very easily see both the wheels actually they should actually traverse the different distance. So this wheel has to traverse more distance compared to this wheel. Okay. So in that particular case, that means the velocity given to this wheel should be more, right? And velocity given to this should be somewhat less. Okay, so that ultimately the once the turn is over, so the vehicle is there only properly. Okay, otherwise you can think that suppose one wheel, this wheel will be here, this will remain somewhere here, it will be lagging off. So that cannot be a possibility, right? So the wheels are mounted on the same vehicle only. So the so this kind of arrangement has been done with the help of this differential and all. Okay, and that's a possibility. Understood?
Yes, sir.
Okay, thank you. Similarly, this spiral bevel gear, it may be straight and it may be spiral bevel gear depending on how the teeth are being cut. So if you see, so the teeth are straight here, so it's a straight bevel gear. So we can also have spiral bevel gear or helical bevel gear depending on the angles, how the depending on the teeth. Okay, how it is being cut. Okay. And there is another word known as the zero bevel gear. I want all of you to just go through it. What is this? You can, by this time already you have discussed most of the thing, so that you can find out. Next, if you can recall the very initial classes, there we have said that the gear drive or gear mechanism generally it's a higher pair mechanism. So the contact between all the teeth and all, okay, generally they are line contact. So if you can see there, the teeth are in contact and generally they are line contact. So it makes them a higher pair. But we can also have sometimes there is surface contact also is there sometimes. So it's which is the case in case of a double-throated worm and worm wheel. So what is this worm wheel and worm gear? Okay, we can. Now, this worm is a cylindrical body with one or more threads cut on it, okay, in the form of a helix. So this particular portion, actually, this is the worm, okay, and this is known as the worm gear or the worm wheel, okay. And this worm, it may be sometimes it may be conical also in shape, so it may not be cylindrical, it may be something conical like this, okay. But they have this one or more thread, this kind of thread cut on it. Now, what we can do with the help of this worm and worker? So basically, if you see, so this is one axis, right? Okay, this is the axis of this, and this axis is going inside your that plane. Okay, so they are neither parallel. This is not neither parallel nor they are intersecting. So in this look figure, it will be evident. So one axis is like this, it will be going past like that, and another axis is like this. Okay, so the requirement may be from this axis to that kind of axis, you may have to transfer the motion. Then this is the possibility. So it is Q shaft. They are neither parallel nor intersecting. So they are used for transmitting motion between non-parallel and non-transmitting, non-intersecting shaft. So it should be non-intersecting, not non-transmitting. Okay. Now, depending on the number of teeth which are engaged, it may be called, it is called a single or double. Okay. And what is the possibility? So here the worm and whorl drive, it is used for very high speed ratio. That is, speed ratio means speed ratio is nothing but the ratio of the driver driven to the driver. Okay, so that very high speed ratio we can get. Okay, so suppose this is rotating it at a particular RPM, so conversion of the this particular motion will be that ratio RPM conversion. Okay, speed ratio will be very high. Okay, so one might be rotating at very high speed, another is slowly rotating. So that kind of thing it can be done. Speed ratio is very high. Okay, and in there this particular worm wheel, okay, it has got a particular property, very interesting property. And what is this particular interesting property? So now this worm, this particular worm, it can easily turn the gear. So this gear, the bigger wheel, which is gear, so it can be very easily turned by turning the worm. But this gear, it cannot turn the worm. So this is one of the very interesting property. Okay, so if you give the input to this particular worm, we can you can expect output of rotational motion in the worm wheel or this particular gear. But even though they are engaged, even though they are in mass, but this motion from this particular gear, it cannot turn the worm. So it gives us a self-locking property also. So sometimes to lock this particular direction, okay, so that even if there is having some motion and we don't want any motion in this particular direction, so we can even use this kind of worm and worm gear to give the or to impart this kind of self-locking property. We have also seen Paul and ratchet mechanism, which also can give you one the locking mechanism. So here also somehow we can use it. Okay, and we have got surface contact between them, makes it lower pair. And in general, for maximum efficiency, the spiral angle of worm thread is slightly more than 45 degree. Okay, so this is basically about your worm and worm wheel. Okay, and there is some words like terminologies, non-rotate or single rotate or double rotate worm wheel. So just go through it from any book, you should be able to understand it. And in the next class we'll be going to the different gear terminologies. Prior to that, just one small thing we'll just discuss, which has already been discussed previously also. And so see, in this particular two figures we are showing two gears which are in mass, and one figure is by showing the only the circle, and another figure which looks like a real gear. So as we have already discussed, so basically this two gears, if you look at this particular two gears, so basically the contact is here at this pitch point, and through this point if we draw two circles, okay, then two gears, this will be known as the pitch circle, actually the circle which is passing through the pitch point, the contact point. So they are actually in contact, so this is this representation, okay, with the help of this circle. So basically this is the pitch point where they are, the gear teeth are in contact. But if I have to draw each and every time like this gear, okay, showing all the teeth and all, it will be difficult for us. So that is the thing. And generally the smaller gear, which is known as the pinion, already we have discussed. The bigger gear is known as the gear, and generally smaller gear is the driver. Bigger gear is generally considered as the driven, if nothing is being mentioned. And sometimes it can so happen that bigger gear, it may be driver also, but if nothing is mentioned, we automatically understand that pinion is the driver, pinion is the smaller gear. Okay, so and this gear is the driven. Okay, and as like we have told, smaller gear is pinion, larger gear is the larger wheel is known as the gear. Okay, and most of the application pinion is the driver. And because of that, what basically will happen if we are talking of pinion being the driver, then we already know from our previous knowledge, okay, n2 by n1 equal to r1 by r2, that is it is inversely proportional to the size. So in that particular case, if pinion is the driver, then this will reduce the speed but it will increase the torque. So how torque and speed, they are interrelated. So in this particular driven side, driven wheel will rotate with a smaller speed if pinion is the driver, but the torque available will be more. So that's why what you see generally in case of, I believe most of you all of you are familiar, even though if you might not have driven car or bike, etc. Okay, maybe you are familiar with it, and you know that when we are talking of ascending the wheel or at the smaller speed level, when we just have to initiate the movement and all, so in that particular case, generally higher torque requirement is there, and whenever we are ascending hill or maybe from the stop to we have to from the stop position we have to move the vehicle. So in that particular case, initially we require more torque, and in that particular case, you know that generally we say that you drive your car in suppose the gear one, first gear or second. Okay, so we say like that, right? Okay, in the starting or maybe while you are ascending hill and all, maybe first gear or second gear, like that. Okay, so in that case, generally the first gear, second gear, they are actually what basically is happening, we engage the bigger gears, and while engaging the bigger gears, what happens, the speed gets reduced but we get increased torque, and that torque is responsible to give the motive force to your vehicle. Okay, and this already we have discussed, because we have seen that n2 by n1 it becomes r1 by r2, it is inversely proportional to the size and all. Okay, and that is how they are. Okay, so with this we'll stop here. You let me know if you have any doubt, or if you have understood, you can also, you just let me know whether you have understood or not. So we'll stop here today. In the next class we'll start from the different gear terminologies. Thank you everyone. Just let me know whether you have understood or not. If you have any doubt, you can ask. So I hope all of you have understood the things. Okay, and we'll meet in the next class. Thank you everyone for joining. I'm stopping.